Student, ready to learn the new topic known as potentiometer. Potentiometer, it is a very high resistance device. As we know, there are four type of devices basically used in physics. They are ammeter, galvanometer, voltmeter and potentiometer. These devices are categorized according to their resistance. The least resistance is of galvanometer. Galvanometer have very low resistance and ammeter have low resistance, voltmeter have high resistance and potentiometer have very high resistance. So you are going to learn about potentiometer. In physics lab, potentiometer is designed on framing on a wooden frame. On potentiometer we required a rectangular wooden block. This is a rectangular wooden block. Here we are taking a rectangular wooden block, and on this rectangular wooden block there is 1 meter scale. This is 1 meter scale, marked 1 meter scale is here. There is 1 meter scale, and we are taking 1 meter scale, and we are taking a number of 1 meter wires. We are taking number of 1 meter wires kept parallelly one over another. This is 1, 2, 3, this is 4. Here we are taking 4 1 meter wire made up of manganese, and these 1 meter wire are connected with thick copper strip. Here we have given one connection of copper strip. Then here we have given another connection for copper strip. Here we have given another connection of copper strip. This is a connecting point. So this point is said to be A. This point is said to be B. So A to B is a 4 meter wire. Now it becomes 4 meter wire. This is said to be potentiometer, which you will get in your physics lab. Now what are the use of the potentiometer? First of all, we are going to find the principle of potentiometer. First, if I ask what is potentiometer, then the answer is potentiometer is a high resistance device. Potentiometer is a very high resistance device. It is used to measure. It is used to measure, number A, potential accurately. Potential accurately. It is used to measure potential accurately, because potentiometer is the device you will see it measure the potential of a battery without using the current drawn from that battery. Number second, use to compare EMFs of two cells. And number C, use to determine internal resistance of a cell. So what is potentiometer? Potentiometer is a very high resistance device. It is used to measure potential accurately, used to compare EMFs of two cells, used to determine internal resistance of a cell. Now next you are going to see principle of potentiometer. What is the principle of potentiometer? For understanding principle of potentiometer, before defining, I am taking this I am taking two wires from outside, from A and B, and connecting these two wires to a battery source, external battery, with a rheostat and a key. This is a rheostat and a key. This is a battery, and from point A we will take a voltmeter. Now switch on the battery. Here we have a jockey, a pointing device. So when you put the jockey at this point, when you put the jockey at this point, let the point is C, then this point cover the joint voltmeter from A to C. So it will show the potential between A to C. If you further move the jockey to another point D, then A to this line, then this line is D. It measures the potential up to this line. So length will changes, potential will changing. How this is happening? Let us see. According to Ohm's law, V is equals to IR. You know that R is equals to rho L upon A. So therefore, V is equals to I rho L upon A bracket. From here you have V equals to I rho upon A. Take out L common. Then this is equals to V equals to K into L, where I rho upon A is equals to K. K is said to be proportionality constant. So you have V proportional to L. So what you have find? We have find that when current and area and resistivity are constant, then voltage is proportional to length of the wire. We know that area is already constant because it is not changing. It is a uniform cross section area wire. We know resistivity is constant because the wire is made up of manganese. Now only the changing parameter is current, but here we have connected rheostat, so we control the current also. It is also constant. So whole three parameters are constant. So V is proportional to L length. This means that this is said to be principle of potentiometer. Principle of potentiometer. How you are going to define it? Principle of potentiometer is defined as voltage is directly proportional to length of the conductor provided the current, resistivity and area through the conductor is constant. This is said to be principle of potentiometer. Now you are going to use this principle to find two uses. Number A use, we are going to see, this is to compare EMFs of two cells. For comparing EMF of two cells, at this junction A, we are taking out two ends wire. Here two wires and connected with a battery. Here with a battery, and these two battery are connected with a switch. This is said to be switch. These are the two switches here. Tapping switch. This is said to be K1 and this is said to be K2. The two switches are, this is said to be K1, this is said to be K2. Two switch are there. From this midpoint we take a galvanometer, and thus this is connected to the jockey. Now step 1, here it is step 1, closed key K. This is said to be K key closed, and K1 is closed. Then after that we slide the jockey over the wire AB. Slide the jockey over wire AB to find null point. Null point is the point where deflection in galvanometer is 0, null point. Let it is at C. Then AC equals to L1. Therefore, V, not V, here I am writing E1 for this cell and I am writing E2 for this cell. So here E1 is proportional to L1. So E1 is equals to KL1. Let be question number 1. Now step 2. Step 2. Open key K1. Open the key K1 and closed key K2. Close the key K2. Then slide the jockey over wire AB to find null point. Let it is at D. Then AD is equals to L2. AD equals to L2. Therefore, E2 is proportional to L2, or you can write E2 equals to KL2, equation number 2. Now divide equation 1 and 2. Divide equation 1 and 2. Here we are going to divide. Dividing equation 1 and 2, you get E1 upon E2 is equals to K L1 upon K L2. Cancel this K. So E1 upon E2 is equals to L1 upon L2. Thus, we know the length of the wire from this scale. Putting the length, we get a ratio, and that ratio is the ratio for the EMF. This is the method how to compare EMF of two cells. Now, the second application is to determine the internal resistance of a cell. For determining internal resistance of a cell, we required only one cell. So this is the one cell is here. This is cell E, and from cell E is connected to a key and a galvanometer, and in here parallelly you connect a resistance box having another key here. So this is key K1, this is key K2. Now step 1, this is the construction for finding the internal resistance. First of all, you do step 1. Step 1, closed key K and K2. Then slide the jockey over wire AB to find null point at C. Then AC equals to L1. So therefore E is proportional to L1. Again you have E equals to KL1. Write it equation number 1. Now step number 2. Closed key K and K2. Then take a resistance R from resistance box, closed key K1 and slide the jockey over wire AB to find the null point. Let it is at D. Then now EMF E become potential because we have applied the resistance R from here. So some current must enter to this resistance. So V is proportional to L2. Here AD is equals to L2. So you have V equals to KL2, equation number 2. Now again you divide equation number 1 and 2. So we are again going to dividing equation 1 and 2. You get E upon V is equals to K L up 1 upon K L2, cancel this K. So you have E upon V equals to L1 upon L2. You have learned in my previous video that internal resistance R is equals to E upon V minus 1 into R. This is equation number 3. Use equation 3. So you get R is equals to L1 divided by L2 minus 1 into R. Capital R is external resistance, and L1 and L2 are the balancing length when for EMF and for potential. So thus, putting the value of L1 and L2, you will get the value of internal resistance. I hope you are understanding physics very nicely, and if do so, then do like, subscribe and share my videos. Thank you.